The first important step to soldering iron safety is making sure that your sponge or wet or paper towel is damp. If you use a dry sponge or paper towel, you can risk starting a fire or damaging the iron itself. You want to make sure the sponge is thoroughly wet at first, and then you're going to want to wring it out to ensure that it isn't soaking wet, but it's still damp. It's then ready to be placed back in the holder. Now that we have a wet sponge, we're ready to preheat the soldering iron. When the soldering iron is preheating, or any time it's on, it's important to make sure the soldering iron wire does not touch the soldering iron tip so that it does not melt and ruin the soldering iron. It's important when soldering to protect your eyes from the fumes. Safety goggles should be worn when you're soldering. This solder does contain lead and is rosin core, which is recommended for electronics. Notice the amount of fumes from just tinning the tip. When possible, you should try to avoid breathing this and make sure that you're soldering in an open, ventilated area. Here we have the solder coiled so the heat doesn't transfer through the wire and burn the user. We're going to be tinning the tip now, which is the only time that the solder will ever come directly in contact with the soldering iron. It's important to tin the tip to make sure that the components will go in evenly. It's important after tinning to remove excess solder on the damp sponge or paper towel. When not in use, it's important to put the soldering iron back in its holder to avoid damaging anything. Next, we'll move on to soldering two wires together. So here we have a wire stripper. This stripper takes off the insulation on the wire on its lowest setting. You set it up so this is a double action so that it strips the wire and it'll pull the insulation off for you. So here we have it set up. And there it goes. If the insulation is stuck like this, you can remove it by hand. We now strip the second wire in the same method as the first. We will now join the two wires in the Western Union tie style. First, the wires are overlapped. Once the wires are overlapped, they're twisted together. This is to ensure they don't come apart. We're now ready to solder them. In order to solder them, the solder is lined up so that it's touching the opposite side of the wires where they join that the soldering iron will be. Keep in mind the solder should not touch the soldering iron. Here we can see as the solder touches, it begins to melt onto the two wires. Here we have a combination flashlight radio which we'll be recycling parts from. We're going to, as an example of desoldering, I'm going to go for that capacitor, the electrolytic one right in the end. It's important to have something to grip it with, like the pliers I have here, as the component does heat up when the solder melts. It's important that you touch only the lead with the soldering iron. Here we can see that by touching just the lead, the solder heats up and the capacitor becomes loose. Now the other lead is not exposed, so we will have to touch the soldering iron to solder. This is not recommended, but in some cases it's the only way in order to remove it. Here we can see it's pulled right out. Careful though, the component is still hot. Always clean your soldering iron tip after using it. So
Here I will show you how to solder components into a piece of PCB
and I'm
board.
going to show you how to solder components into this. So we're going to start with...
The spacing is standard size for components on this board.
Light theremin.
Here we have a prototype of a light theremin.
Which currently isn't hooked up.
We'll start by working with a 555 integrated circuit. This integrated circuit has 8 pins. Each pin must be lined up and unbent in order to fit into the holes. It's important when soldering this in that the pins do not touch. To start, I'll bend one pin down on each side of the chip in order to keep it from sliding out while I'm working on it. Each of these 8 pins will have to be soldered in individually in order for the chip to function properly. We're taking the same solder from before and lining it up so that the soldering iron is on one side of the pin while the solder is on the other side of the pin. The first pin is now done. We will repeat this step 8 more times in order to fit all the pins. More than likely, most components you'll be working with will not have pins, but instead will have 2 leads. This is a light-dependent resistor we're using. It's being reused, which is why one of the leads is missing. In order to set this up, you have to thread both leads through 2 holes on the perf board. It's important to keep in mind that the 2 leads should not touch once they are in there. Once it's in, it should rest almost flat upon the surface of the board. Once it's in, one lead should be bent down in order to keep the component from moving out of the board. We'll start by soldering that component. We'll use the same method we did on the integrated circuit by touching one side of the lead with the iron and one side of the lead with the solder. We'll start with the smaller lead first. Once that's soldered in, we'll move on to the larger lead. Now, because this lead hangs down so much, we'll have to trim it down. If this lead is not trimmed down, it can lead to that lead touching a lead it's not supposed to and shorting out. It's important to clean your soldering iron after soldering. In order to trim the lead, we'll be using a pair of wire cutters.